So you will hear some thoughts from me on what I've been seeing, what I've been digging into the past couple of months, along with the other projects that are ongoing. So with this, almost everybody knows the SARS-CoV-2 virus has caused an unprecedented effect on human life, the global economy, as well as the environment. Okay, so I'll touch upon all these three aspects as I go through the next half an hour or so. So the pandemic with the coronavirus has taken a huge toll. The latest numbers are about 9 million globally and little over 2 million in the US, and about little less than 500,000 people have died. And I do want to acknowledge and take a moment to think about the lives that have been lost and the families who are hurting right now. So switching gears from here, with humans in hiding, so with the pandemic, what has happened is about half of the current population that we have on Earth, 3.6 billion people or so, were on lockdown when the pandemic hit and as the pandemic was spreading across the world. And a report came out from one of our Institute Board of Visitors members, Pavel Malchinov, with the investment banking firm Raymond James, sent a report out a couple of months ago, and that got me thinking to see what was happening. So with a large population of the world currently on lockdown, and as you see in the last couple of months, with so many people initially on lockdown, about 2/3 of them are already slowly starting to ease back to doing the routine things slowly. But in this period, the animals have taken back our planet. During this lockdown, you see that species of all kinds of emergent areas that are previously crowded by humans, illustrating how the ecosystems can rebound with speed once human intervention subsides. So this was fascinating. And what I'll show is a series of just pretty pictures showing what humans being on lockdown has meant for the animals in the ecosystem. Starting with thousands of birds, this is Lima, Peru. Thousands of birds by the beach. So there was no human activity by the beach, and you see all these beautiful birds by the beach. To a coyote near Golden Gate Bridge in our own San Francisco in the US. To flamingos on the wetlands in Mumbai. To lions in the Kruger National Park in South Africa. So no tourists in the national park, and we have lions strolling and sleeping on the park roads. To dolphins on the Bosphorus in Istanbul, Turkey. To a puma on the streets of Santiago in South America. To wild mountain goats that came from the mountains to this little small town in Wales. To a majestic peacock strutting herself on a shopping spree near a mall in Dubai, United Arab Emirates. To penguins in Cape Town and pelicans in London. To turtles in Thailand. So we have the largest number of turtle nests apparently have been found in Thailand in over 2 decades. So what you see is as the humans taken a hiding from the pandemic, you see all these animals coming out from where they were. Marine life is being restored to some degree, like we saw in Thailand. So now we'll switch gears quickly to talk about what the pandemic has meant for energy demand, specifically on CO2 emissions. And after we get a sense of what happened with energy demand and CO2, we'll talk about what this meant for transportation and then on air quality. So when the pandemic at the peak of this in April or so, we saw the change in electricity demand was pretty drastic, where coal-based fossil fuel generation dropped over 15% in March. And then by the first few weeks in April, a third of the demand dropped. And by the first quarter of 2020, the projection was global electricity demand will fall by about 5% by this year. Then looking at oil, there's an unprecedented scale of drop in demand for oil. So on the left, you see the road transport activity by major countries of the world, and as well as the whole world. Then on the right, you see the reductions in aviation activity, specifically flights. So if you look at the transportation change on the left, you have over 50% drop in road transport activity in several countries. So globally, by the time we hit April, we had a little over 50% drop in road transport. And then aviation activity came pretty much to a standstill in several countries, but globally we had over 60% drop. With all of the reduction in mobility, oil demand dropped quite a bit in April by about 29%, with the projection to have total drop by about 9% by the time we have the end of this year. So that was the projection. So you may recall in April when we had oil prices drop really, really low and people are sitting with excess oil. and it was in fact the futures were trading negative at some point in the month of April. So global energy demand, just picking up the thread on the global energy story. If you look at what happened to the entire century, so far, starting from early 1900 to now 2020, you see how the energy demand went up and down. But I do want to point out a couple of key global events, starting with the Spanish flu in 1920. You see how the energy demand went down quite a bit during the flu to about 15 to 16% drop. But what happened right next year was from a 15 to 16% drop, the next year's demand went right back up to over 20%. And similarly, if you look at the recent global financial crisis we had in 2009, we had a large drop, but then right after that next year, we had an increase. So in both these cases, what I want to highlight is when disaster strikes, we have reductions in energy demand, but the very next year, we go right back up. In fact, more than the previous reductions. So if you look at the energy demand right now, we had a 3.8% lower demand in the first quarter of 2020, and the projections are for about a 6% drop for this year. So what does this mean for CO2 emissions? On the left is CO2 emissions again as of April. You see the CO2 emissions growth for the past 100 years or so. And on the right is a daily change in CO2 emission. This is a recent study that came out and got a lot of press from a group in the UK. You see daily changes in CO2 emissions. And then again, this red that you see here is this single day drop. So what we saw was CO2 emissions were changing quite a bit over the past century. But then with the pandemic, we had an 8% drop in the first quarter of this year. And this was much larger than previous drops we had seen globally. About 6 times larger than the drop during the 2008 financial crisis, and almost twice larger than all emissions reduced since World War II. With all of this, economists and actual scientists have estimated that these emissions reductions in the first quarter of this year would suffice to limit global warming to 1.5 degrees above pre-industrial temperatures, which is the Paris Agreement. But this particular number is of interest, this red line that I show in 2020 for a single day. This is a paper, like I said, the one from UK that came out last month. This got a lot of attention. And what they said was, in one day, they did an analysis of about a month during the pandemic. And for a single day in April, April 7th precisely, they estimated that over 17% reduction of total CO2 emissions happened on that single day. And you can see how this varied across the different sectors. Power range from 7% reduction to industry, 19%. Surface transport, this is the on-road sector, 36%, to aviation had the largest drop, 60%. So overall, we had a 17% reduction. And based upon this, if this were to continue, depending on how much we are all confined during the rest of the year, the total annual reductions may be somewhere in the 4 to 7%, depending on how much restrictions we may have worldwide through the end of 2020. But amidst all of this, as CO2 emissions were going down, the renewables portfolio started to grow. You see that the wind and solar share of global electricity generation went up by 9% the first few months of this year, which is twice what we saw 2 years ago. So this was a positive where we have fossil fuel-based emissions going down. The role of renewables in general across the world was starting to grow up. Okay, so what does this mean for transportation sector in the US? So I'll focus quite a bit on the US transportation to see what this meant during the pandemic as we were staying in confinement and shutdown. So if you look at vehicular activity, this is total vehicle miles traveled. It's a measure of how much on-road activity happens in the US. So this number is in trillions. So you see the growth in vehicular activity over the past decade or so. Very nice growth all these years. But then during the pandemic right now, we had an 18% drop in US-wide vehicle miles traveled this year compared to last year. So that's what we saw nationwide. Then if you look at this little bit on a smaller time scale, so this is data where you're looking at weekly activity in total passenger miles traveled. This is just passenger cars. These are cars that you and I may drive to work or not. And if you look at this starting from the first week of March to last week, this is total passenger vehicle travels. So assuming if you have 100% vehicular activity on February 29th before the shutdown, then you look at every week since then, you see how the averages, we hit a nice trough in the first to second week of April. But since then, we have started to climb back up a lot in the last few months since the trough. So we had a 50 to 60% drop in early April, where personal travel was a lot down because we were all staying indoors. But since then, travel has increased quite a bit, and almost all the major metro areas of the US are seeing activity in terms of bringing back to normal from what we had before. But while passenger vehicles went down, freight did not go as much down as possible. Okay, and you may think about us staying home. We're doing a couple of things while we're staying home. We are staying home, maybe doing teleworking and such, but then the demand for goods did not go down, which means we are all doing this online shopping, so to speak, from the Amazons and the Walmarts and so on. And this is leading to more freight activity than what we saw before. So if you look at the passenger travel based activity going down on the left-hand panel, on the right, we see the freight did not go down as much as passenger based travel. So in some areas, in fact, some urban areas, the numbers from this both Federal Highway Administration and this data provider called INRIX show that several urban areas of the country had increased freight activity, which led to other air quality issues in the near field in urban areas. So this is a key message that passenger travel activity went down, but freight did not go as much down as passengers, but we do see a small increase in some urban areas. Now, if you look at the overall passenger travel activity patterns over the past few months and how this compares on a state-by-state basis, this is an interesting chart created by one of the data providers. And what they show is, you look at vehicular activity on a week-by-week basis for every state in the US, and you have, of course, the US-wide average in the middle, and you see how much the weekly vehicular activity changed compared to the pre-pandemic or the pre-shutdown period. So the gray bars show for every state, or the US, for example, what was the maximum decrease for a single week compared to pre-pandemic. So if you look at the US nationwide had a little less than 50% drop in vehicular activity at some point in the past few weeks. And if you look at the 2 recent weeks when data were compiled, so this is the red and the dark blue colors. So you see for May 29, this change has gone down from a little less than 50% to only 16%. So slowly you saw that the vehicular activity patterns have started to increase now. And these increases are ranging from about 49% in the case of Hawaii to Wyoming, which is minus 21%. So you have more cars now in Wyoming and South Dakota and Montana and so on than what you had in pre-pandemic. If you want to see what happens in North Carolina, so we went down by as much as about 45% at some point in the past few weeks, but now we are only at 13% or so compared to the pre-pandemic period for the period ending May 29. So this gives you a flavor for which states have more mobility and which states have less mobility in the past few weeks. And you can see what is the maximum reduction compared to the pre-pandemic phase from the gray bars. A specific example from one of the most densely populated as well as most busily traveled sections of the city in Los Angeles. This is Highway 110. This is a picture taken during the peak of the pandemic. You see pretty much empty road, which is otherwise having bumper-to-bumper traffic. But on the right, what you see is how the speeds have changed. So historically, if you look at how the vehicles are moving and the average speeds, if you look at this diurnal pattern in the yellowish colors, you see how vehicular speeds dropped quite a bit during peak rush hour in the morning. You were somewhere between 20 to 30 miles per hour in the morning. And again, in the evening, between 6 to 7 p.m. or so at 30 miles per hour. So that was the average. But during the peak of the pandemic, you see this orange line at the top when vehicles are pretty much cruising along at 60 miles per hour. So this is pretty much abnormal for this part of the country. But what this also means is when you have vehicular emissions going down at these lower speeds with higher speeds, you have higher emissions coming out at low speeds, but higher speeds, you have relatively less emissions. So this also has an impact on the environment. So you have a lot of congestion, which led to higher emissions early on in this part of Los Angeles. But of course, during the pandemic, you had free-flowing traffic at 60 miles per hour, which led to relatively less emissions. Another issue, this is New York City, another example, just moving across from Los Angeles to the East Coast, New York City. So FedEx, of course, delivers a lot of goods. And this was an article in the New York Times late last year, which said that FedEx delivers about 1.5 million packages a day. So while we are moving towards e-commerce, this also meant a lot of vehicular activity in the city. And as part of congestion in the city, earlier trucks were heading to the city, which are traveling at say 23 miles per hour or so on average, which is used to be 30 plus miles per hour before. So you see how vehicular speeds have gone down because of congestion. And cars in downtown Manhattan were crawling at 7 miles per hour, which is almost a third slower than what was happening a decade or so ago. But this was pre-pandemic. The question is, post-pandemic or during pandemic, what really happened in the city? That's something we have to look at to see what happened. Did emissions go down because of less cars in the city, or because of more online e-commerce and this FedEx and UPS vehicles bringing goods, did emissions go up? So that's a question that I'm exploring to see what happened in the city. Okay, let's move on to actual air quality from the impacts that we saw, impacts of energy demand, we saw impacts on the transportation sector. Now let's focus on what happened with air quality. So air quality, as probably everybody on the call knows, we have air quality and air pollution occurring from global to regional to urban to city scale or street level air pollution. And one has to look at the interaction between the various physical, chemical processes at all these different scales. And in terms of the relevance of air pollution, recent study from the Global Burden of Disease study from the World Health Organization and this institute called HEI put out numbers which said that we have about 5 to 7 million people dying prematurely due to air pollution globally, out of which little over 100,000 people are dying prematurely in the US alone. And the key pollutant that driving this is fine particulate matter. The other pollutants of interest are ozone, which is not primarily emitted, but formed in the atmosphere due to reaction between emissions of NOx and volatile organic compounds. And then other key pollutant is NO2 or nitrogen dioxide, which is an indicator of combustion processes. We'll look at these three pollutants a little bit to see what we saw during the pandemic. So some pictures and some news report that came out during the pandemic. People started to see a lot more through the atmosphere than what they used to before. Here is one example from India, which said the Himalayas were visible for the first time in several decades from a state in northern India called Punjab, where they said the Himalayas were visible, which is over 100 miles from where this particular picture was taken. And this happened after several decades. So one guy woke up one fine morning in the state and said, oh my God, I can see Punjab, the Himalayas now, which he does not remember seeing for many, many years. Blue skies in New Delhi. New Delhi has been notorious in the past few years for air pollution during the winter seasons. And now suddenly we see blue skies in New Delhi. Here on our own Los Angeles here in California, from the city of Los Angeles, people could see blue skies as well as snow on the San Gabriel Mountains. At one point, Los Angeles was called the smog capital of the world. And based upon air pollution measurements and the air quality index that the EPA and the city puts out, if you look at this, this is a long-term time series looking at air quality indices in Los Angeles from 1995 to 2010, looking every month. And during this period, 2010, if you look at this period in March, LA had the longest stretch of clean air based upon measurements of PM2.5, which was causing this air quality index at that point. So in over 2 decades, LA had one of the cleanest stretches of air for almost 2 weeks or so. You see this nice green color, which is the code green for air quality. NASA in the US and ESA in the European Space Administration, they both have their own satellites up there measuring air pollution, specifically NO2. So this was the first satellite-based retrieval looking at air pollution. This was put out by ESA's Sentinel-5 satellite. They have this instrument, Tropomi. So what they saw was from China. So if you look at the pre-pandemic on the left and the during the pandemic period, the period for February 10 to 25, you see very nice reductions in NO2 in this part of China. So this was one of the first reports that showed satellite-based retrieval looking at relatively clean air. And NO2 is a nice indicator of combustion. You saw how much fossil fuel-based emissions are being reduced, and hence reductions in NO2 in China. And here's another analysis which showed, so the Chinese New Year happens in the middle of our English calendar year. And you saw how in the top panel, you saw the period in 2019, the period in January, you have high NO2. And then during the Chinese New Year, you have reductions, of course, because Chinese New Year times, you have general vacation, people go back to their homes and so on, and industry shuts down a little bit. But after the Chinese New Year, the top right panel, you see how in a normal condition, you have production bringing back up and you have high levels of NO2. This was all the story for 2019. If you look at the bottom row in 2020, you have, again, the pre-pandemic Jan 2020, and then the Chinese New Year in the bottom middle, and then the post-Chinese New Year, but now you're looking at the pandemic, peak of the pandemic, you see that the recovery in air pollution, so to speak, did not happen. So this is, again, an indicator of how the pandemic shut down human activity, and the NO2 levels are reduced quite a bit in China. Meanwhile, in the US, from NASA's Aura mission, which has the OMI satellite, or the ozone monitoring instrument, looking at what happened in the US, comparing a 5-year average in March from 15 to 19 to March 2020, you had NO2 levels reduced by over 30% in the northeastern US, and similar levels of reduction in the southeast as well. You see how you have NO2 in the southeast, and here we are in Chapel Hill. You see pretty much a clean color here in the middle part of the state. But you see earlier in the 5-year average, these warm colors, orange to red in the southeast. And since then, in South America, given the pandemic, continued confinement and shutdowns, we have continued 30 to 40% decrease in several urban areas of South America since mid-April. You see Rio de Janeiro, one of the largest cities, have a 36% change. Buenos Aires, 40%, Santiago, 36%, Lima, nearly 70% drop compared to a previous 5-year average. So you see how NO2 levels are reduced quite a bit during the pandemic, again, due to reductions in fossil fuel-based combustion. But since then, now looking at more recent satellite pictures, NO2 is rebounding back. So on the left, you have the February period again that I showed a couple of slides ago. Now you're looking at the April to May period, and you see how NO2 is now picking back up because the economy is opening up, and then a lot of activity is resuming since then. And now you see how we are starting to increase fossil fuel-based combustion and hence levels of NO2. And if you look at a time series of the same data, so this is on the x-axis, we have time in terms of number of days since the Chinese New Year, and NO2 levels on the y-axis. You see the average of the previous 5 years in the 2015 to 2019. And then you see how the red line tracks the period 2020. The shutdown had a large reduction early on since the Chinese New Year. But since then, more recently, you see we are almost back to where we were for the previous 5-year average. Looking at PM2.5, this is one of the most important pollutants, fine particulate matter, and you see how we have reductions of PM across the country, across the world, changing quite a bit depending on where you are, from 25 to 31% or so in the East Coast versus West Coast in these two major cities, and across the world you see some fairly large reductions in PM2.5. So these are based upon measurements that are coming out. But a lot of people are starting to look at this data and seeing what is happening with the air pollution-based trends, specifically in the US as well. An unpublished study for the US, I don't cite this, but an unpublished study says even within the US, while you see these very large reductions in some urban areas, across the US, if you look at it on a US-wide average, the reductions are not as stark as these numbers show, and we may be having pretty much par for the course, so to speak, compared to previous years. But the data is being analyzed more and peer-reviewed. So with all of this, while I showed a lot of examples of reductions in NO2 and PM2.5, it is not clear if the COVID-based shutdown has led to uniform reductions in all air pollutants. Okay, it's very clear if you look at just NO2, which is an air pollutant from combustion, it clearly went down, and NO2 has very adverse health effects as well. Specifically, it enhances, aggravates asthma conditions, breathing conditions in people, and a lot of pediatric asthma cases are found all over the world. So we would see reductions in health effects based upon NO2. But if you look at PM2.5 levels, these may not have gone down uniformly across the US. You see fairly large reductions in some urban areas, while in others, it's fairly small or even status quo, so to speak, during the peak pandemic period. And this is an indicator of several other sources, because PM is not just a function of transportation emissions or fossil fuel combustion. A lot of other activities go into forming PM2.5. So you may have had increase in residential wood combustion, depending on where you are in the country. Soot from trucking activity, this is the freight that I mentioned earlier, where freight activity did not go down as much as passenger activity. And then backyard barbecue cooking, as the summer is on us, we have more backyard barbecue cooking, which leads to emissions. And then household electricity consumption has increased. So most of us staying home right now, instead of at our workplaces, electricity consumption at homes have increased during the daytime. This is typically when some of the power plants or some other private industry put on these dirty generators, okay, which tend to be more polluting than some of the large power plants which have federal and state mandated control technologies. And then PM2.5 has both acute as well as chronic health impacts. A lot of studies have established over the years. But then based on what you saw right now, the pandemic-based shutdown, we may have had gains in acute form of PM2.5 exposures, but not in chronic, because the long-term exposure is not reduced as much because of the economy opening back up, and we have reductions being reversed right now. Another key issue is ozone, a secondary pollutant. The levels of ozone may not have actually gone down, they may actually have gone up due to low NO2 levels. And this speaks to a complex nonlinear chemistry we have between NOx and ozone. High levels of NOx tend to eat or reduce ozone. So as NOx emissions are going down, that particular process to reduce ozone is removed, and hence we have increases in ozone. Specifically, one study came out from Spain, Barcelona, which showed that when NO2 went down by 50%, ozone actually went up by 50%. It's not that much linear, but you see the impacts of, while NO2 levels going down, you may be offsetting the reductions in ozone, and this in fact went back up. This is a pretty stark increase. 50% NO2 reduction led to a 50% increase in ozone. And we may be seeing patterns like this in the US as well in specific areas, but those analyses are happening as we speak, and we should have more. With all of this specifically within our group here, what we're doing is, here's some ongoing as well future research ideas. You saw me talking about the traffic-based activity changes during the pandemic. And over the past few years, I've been working with Google's Waze to harvest the Waze data, specifically looking at the traffic activity patterns, how that may be changing at neighborhood scales. And working with another data provider whose access I got pretty recently to look at how we can look at traffic activity data, both for passenger cars as well as for freight activity, and look at changes in on-road traffic activity in the US, and do two different things. One is specify these changes in traffic activity and look at what is happening in the near road environment at very, very local scales next to a highway, as well as use complex 3D models and complicated sensitivity techniques. We have been developing these techniques over the past few years to see how to use sensitivity modeling and air quality models to assess changes in air quality and track specific sectors and how they may contribute to air quality changes, and then quantify the associated health benefits due to a function of these particular changes. And then look at other transportation sectors such as aircraft. We've been working with aircraft emissions quite a bit the past few years to see how that may be translated to aircraft activity going down during the pandemic, to reductions in emissions, and then associated air quality health risks. And then connect to health incidence data during the month of April, the peak pandemic period, to separate two things. So a study came out from Harvard a couple of months ago that's being peer reviewed as we speak, to show how air pollution may in fact have aggravated COVID-19. So that's one direction where you have air pollution aggravating COVID-19. But then what I'm more interested in, what I showed so far, is how COVID-later shutdown has impacted air quality. So you have this nice sort of back and forth here, or a bounce back. So to see how we can use health incidence data from the month of April to really separate the effects of air pollution on COVID versus effects of COVID on air quality. With that, now I'm just going to wrap up. the deadly pandemic with the sudden economic collapse is no way to sustainably restore threatened ecosystems, but it does show very clearly how the wild world responds when humans take a step back. When disaster strikes, this was a very good example of how collectively the whole world stepped up and tried to protect ourselves. But then during all of this, while I showed CO2 emissions going down, a recent report came out that actually CO2 levels hit a record high last month, okay, despite the pandemic. So you see how even these short-term temporary reduction in CO2 emissions has not made much of a dent in the long-term CO2 averages. The pandemic has given a unique opportunity, in my perspective, to take advantage of this forced natural experiment. So this is where this is a fascinating experiment. Well, of course, it came at a very expensive cost to both the economy and human lives. But what this has allowed a lot of us is to take advantage of the forced natural experiment to study the environment. So what I mean by that is we use numerical models quite a bit, where if you want to take an assessment of how a specific source sector contributes to air quality or climate, you have to have a multiple round of modeling where you turn on or off a specific sector and then do either a finite differencing based calculation or use sensitivity techniques to assess the incremental impacts of a specific sector. And doing this with measurements is almost impossible, because the measurements, you measure the total air pollution from a given location. But what the pandemic has done is, because of reductions in fossil fuel-based combustion, reductions in transportation activity, we did have an experiment where you have this sector, so to speak, the transportation emissions, turned off. And you saw the numbers that I presented earlier, somewhere between 40 to 50%, depending on where you are. And it allows us to vet the models a little bit carefully to see what happened, and then continue doing more experiments like this from a modeling perspective while learning from this forced natural experiment. Air quality improvements due to the pandemic-related shutdown is not uniform, as you saw earlier, for all pollutants, not in all places, but it does show potential for what can be achieved while also highlighting the complex nature of the atmosphere. But the key I want to point out here is we all collectively need to think about what happened with the emissions increase. The couple of examples I showed earlier, where after the Spanish flu pandemic, we had emissions going back up by more than the levels that went down. And the same thing happened after the last economic downturn as well, in the 2008 to 9 time period. So think about what happened then and avoid what happened with that particular period, and see if we're able to come back and open the economy in a little bit sustainable manner. There is a potential for broader changes in public attitudes, not focusing on the short-term drop in emissions, but take that as a lesson and really focus on what does this particular trajectory look like in the next decade. In other words, what is the approach to addressing emissions and climate impacts over the next decade, and really focus on how to innovate for the future. 2020 is not a model for cutting emissions, okay? This is not how we want to address the environment. Yet we may start to see a paradigm shift in work and lifestyles. And two examples I have is two large companies, one in the US and one in India. In the US, for example, the Twitter announces that all employees will be allowed to work from home forever. Okay, just think about this. We're all at home now, right now. And Twitter said it allows employees to work from home forever. And in India, one of the largest consulting companies, TCS or Tata Consultancy Services, they have a large workforce of about 450,000 people. And they said almost 3/4 of their employees can work from home by the next 5 years or so, okay? And they need only 25% of the workforce in office. Just think about this, right? This could be the new normal, where a large employer says, either 3/4 majority, or in fact, all of them, like Twitter, can be allowed to work from home. This is coming, okay? This big shift in work and lifestyle is coming very soon for us. And this may spur even more unforeseen changes due to changes in societal demands as the pandemic forced upon us. With that, I want to thank a lot of my data sources, including our own IE Board of Visitor, Molchanov, and his firm, Raymond James. So thinking about some of the global impacts of energy demand and the associated changes in CO2 emissions. And I want to stop with one particular slide. This is one of my favorite slides studying air pollution over the past 2 decades or so. This is from the US EPA. This shows how during the past 3 to 4 decades in the US, we have had drastic increases in GDP, vehicular miles traveled, in population, energy consumption. All of this happened, that is positive growth in economic indicators during the past 3 to 4 decades, while keeping an eye on the environment. So the bottommost curve shows how the primary emissions of various key pollutants went down over this 3 to 4 decade period. So we had about 60 to 70% reduction in aggregate emissions over this period, while the economy grew over 200%. Okay, so this was thanks to the Clean Air Act legislation in the US, which had a very sharp laser focus on public health. Okay, so I just want to conclude with saying that economic indicators of growth can stay positive while we all not take our eyes off the environment. With that, I'll pause and happy to have more discussion.
Hey everybody, this is Emily. Yeah, let's go ahead and open up for questions. So if you want to ask a question, please unmute yourself, and we'll try not to talk over each other. And if that starts to happen, we'll go to another, we'll go to the chat box for questions. So whoever has a question, go ahead.
Rob, that was great. Yeah, probably pandemic is not a great way to manage resources and do restoration, although it certainly provides, right, this amazing experiment. Have you run into, this is a little bit of an aside, but have you run into any privacy issues trying to use things like Waze data and information that connects like you to people's phones and their real-time information and stuff like that?
Absolutely, yes. Okay, so what Waze allows us to do is to track activity as a function of speed, but I'm not able to get actual counts. So this is a conversation I've had multiple times with Google, who now owns Waze, who owns Waze.
Right.
And I've kind of pitched at them quite a bit to give me actual counts, and they have been given a very clear mandate from top down to say never ever give actual count. For example, if you have very less traffic in some place and you have, let's say, 2 cars on a given road, using a couple of different data points, you can really track who those 2 cars are. Okay, and the managers have been told very clearly by their legal team, never get to a point where Google is on the front page of New York Times because they gave the data. Okay, so I've tried to get hold of data, but it's not coming, at least as of now. What we're getting is gross activity as a function of looking at how vehicular speeds change as a function of congestion, but not the actual counts.
I wonder if there's some kind of software now that could sort of look into the future and the same type of circumstance that may happen. If there's some type of software that can be developed that does what you need it to do, but also preserves privacy, that we've maybe never had quite the same need for, but now all of a sudden we're like, this is going to happen again, and we're going to want to collect the data. So are we going to be ready to collect the data, excuse me, the next time?
Yeah, I think that there are some research initiatives ongoing to harvest phone data, right? So there are APIs being developed to track people's phones. This is, not through one of the bigger companies like Google or Waze and such, but the research initiatives where people are harvesting phone-based movements. So we all have the GPS turned on in the phones. We all move around with the phones on, and trying to see from the phone-based GPS movements if we can get to something like this. I think that there are some research areas there that we can harvest.
Interesting, very interesting. I haven't forgotten about the drone tower. Thanks, really great.
Got to get back to that, yeah, absolutely, yes, Susan.
Really good, interesting stuff.
Sarav, this last picture is extremely interesting. This should be on the front page of the New York Times and the Washington Post. Because we hear these arguments, oh, we can't have environmental control, it'll hurt the economy. But look at this, look at this. I mean, this is very, very important, especially these days. So how do we get this out? Can we get this out, Emily? Can this be put out as a UNC thing out to the public? Or Sarav, do you mind having it go out to the public?
Oh, absolutely. This is public information. This is an EPA-based slide. But from all the analysis, I really think this is a very powerful indicator of how we need to keep focus on the environment with focus on the public health. And environmental controls do not have to happen at the cost of economic growth. I think that's the key, right? You see how this very nicely illustrates, GDP went up during this period by 250+%. okay, while we had reductions in primary pollutants by 60 to 70% during the same period, right? So
Yeah.
people often think, oh, environmental controls means you cannot have growth in economy, and this is not true.
It would be great to take this and then also map alternative energy sources. That, you know, dig a little bit more specifically into certain industries that may really sort of start to explain a little bit of what you see there with regards to the emissions drop.
Yeah,
That's right. Yeah.
Yeah, but that's suggestions. This is data. These are facts.
Well, no, I'm suggesting you track the real data in investment and installation and energy use and creation from those other sources. I want to use real data. It would just be of a little bit finer scale data rather than taking an industry as a whole. It'd be cool to kind of break down the energy industry a little bit more specifically now.
Yeah, well, I mean, you know, there's been all this gripe. Oh, the pollution controls on the cars make them all this terrible stuff.
It's always been like that.
More vehicle miles traveled while total pollution went down. Well, we don't have the emissions from this sector on this graph, but those emissions have gone down because the cars are cleaner.
From the days of the catalytic converter, right? Everybody's always made that argument every time, and it's never, you know, no one will own a car. It's too expensive.
I think we need to enlist some of the environmental economists who've come to UNC in the last few years, because, you know, correlation is not causation, right? And there are all sorts of other economic drivers that could have been happening in this same period of explosive growth in our country that could have influenced these data.
Yeah.
That's right. And Kathleen, not to mention that we could not do more, okay? There's obviously a lot more to be done, but this still shows that to some extent what is possible.
Oh yeah, very exciting. I just want us, if we're putting things out, I want to make sure we've done sort of the most basic vetting so that we can have a stronger message. How about that?
Sure. Yeah.
Sorry, but so in these 50 years of graph, there has been controls applied to some of these, right?
Oh yeah. The what is that? Purple and magenta color at the bottom, right? Shows emissions went down because of controls.
Yeah.
This whole thing is due to controls, right?
It'd be fun or cool to see like where the controls were and like if it, you know, actually what it did, you know, and
where in the US?
Where in time?
Where in time? Yeah. There are multiple analyses, but this is sort of one cut which shows the key economic indicators which are being positive while emissions went down. And these emissions went down because of Clean Air Act based legislations, which targeted some of the largest sources of pollution and controlled them over this period.
And EPA did its job.
Says a former EPA employee, Frank.
You're right, though, Frank.
Yeah,
right?
right,
I mean,
I'm not
a big deal.
Disputing that. You're absolutely right. Yeah, and EPA continues to do its job, right? But we are seeing mixed messages right now in terms of reversing some of the environmental norms and declining of science and so on. So EPA needs to continue doing its job and focus on how we can continue looking at protecting the environment and the health while looking at the other environmental indicators.
Any other questions or comments or discussion?
Sarav, what are your next steps? Do you guys have, are you formally pursuing some specific funding, or is there, what are you guys up to now with this?
Yeah, I am pursuing some formal funds, but I have a lot of ideas. This time seems to be the question.
I know, I hear you.
Yeah, I have a lot of ideas. Two specific things is to really get a grasp of what happened to air pollution in the US, right? If you look at what people are doing, what is coming out, there's a mixed message, and I don't see a very consistent, clear message. And I showed illustrations of what is happening in some sectors, some pollutants, but comprehensively, I don't think we have a clear sense of what has happened during the pandemic for air pollution. It is a complex issue, not to belittle that, but at the same time, there is an opportunity to take this pandemic-based shutdown and look at this a little more carefully, both using surface measurements as well as satellite retrievals. I think that's where the power is. And the other is some of the ideas I talked about in taking advantage of ongoing work and expanding beyond that to see how the reductions in transportation sector can be quantified and tied back to specific health instance data. So that's something I'm pursuing with some ongoing work and see if we can leverage this beyond what we are currently scoped to do.
I was just kind of thinking about deposition, right? So it affected deposition too, and there's all the wet dry network out there. I wonder if they detected.
Yeah, funny you should mention this. I am talking with somebody that you know, Larry Band, who studies this, right? So he and I had a chat a few weeks ago to talk about how we can look at Chesapeake Bay, for example, and see what is happening there with the reductions in air pollution and seeing how deposition may have changed nutrients, right? And so we talked to some, and we have to pursue our conversation again.
I should check in with the NC State network. They run that North Carolina network. I wonder if they've posted anything on it.
Okay, yeah.
Very cool.
Yeah, that's a good source to talk to as well.
Cool stuff.
Sarav, it's Brian Bryce. Thank you so much for your presentation. Fascinating information, and your last comment about health effects is very interesting as well. And can the correlation be made to the reductions that you've described to us in that regard, and that might make for some further very interesting research. And also, from earlier in your presentation, I found it very interesting as to the overall reductions and how even information from 1920 and from the real estate recession, depression, 2008, 9, and 10, that time frame, and then the spike back up is kind of interesting. Folks have talked about with more telecommuting and all of that, whether or not the spike back up may not be as intense, given that there may be some changes in the way folks conduct office meetings, office work, all of those different things. And, those are all big question marks. And so checking to see whether that spike is consistent with the others as things sort of pick back up, or maybe not, due to possibly, systemic changes about how we do business in some ways, will be interesting to chart or, focus on as things move forward. But thank you so much for your talk, and I appreciate you being involved in our bagel breakfast. Thank you.
Absolutely, Brian. Thanks for the comments. Yeah, that's really the key, to see if the emissions would spike back up as we saw during those two major previous economic indicators, right? Then we are in trouble. So my hope, being optimistic as I am most of the time, is we learn from those lessons and really not get back those levels, right? Though I must confess that initial indicators are we are climbing back up, but we need to see something drastically change and really think about a sustainable return back to normalcy.
Sarav?
Yes, Frank.
I think we're going to have another natural experiment in this weekend with the dust coming from the Sahara. That is not benign. The particles themselves are dangerous, but what's on them is also dangerous. The UV does not penetrate that cloud, so the lower layers of that cloud can have a lot of biological crud on them. And it would be interesting to see what the hospital emissions look like a couple of days or maybe a week after that hits North Carolina, because it's going to hit the western part of the state first, and then gradually come east, given what the met people at RAL were saying last night about how it's how it fits into the modeling of the transport of the dust.
That's right. Yeah, I'm tracking that through satellite images that are being put out by NASA and others to see how everybody's getting ready for that. That's a good idea, Frank, to look at hospital admissions pre and post that event.
Yeah, there was an experiment done in Puerto Rico, the easternmost point in Puerto Rico, looking at stuff coming into a pristine water, an artificial pristine water tank, where you were having the dust deposit in there, and you could then measure what was in the dust. This was a set of observations done about 10, 15 years ago, and it's not benign. There's a lot of nasty stuff there.
Okay, good to know.
Sarav,
Yes.
I was reflecting on the comments you and Brian were just exchanging, and you used the phrase a sustainable return to normalcy or something like that. So who do you think needs to be involved in conversation, you know, sharing this information that you shared with us this morning to really facilitate thinking about how we return to normalcy in a way that is more sustainable than what we had? Like, who are you engaging with, and you know, where do you think those conversations need to go at a decision maker level?
Yeah, really good question. I think some of this has to happen at a higher level, but I think at the end of the day, the local government has a large role to play in how we come back to normalcy. So talking to the local administrators and the powers that be in making those decisions, I think is key. So we need to articulate internally to see who are the decision makers at a local level. By that, I mean city, county, state, right? That's the level I'm talking about. To see how to engage with them based upon what we know and how to facilitate decision making at that level based upon the knowledge that we are gaining.
Yeah, great, thanks. I mean, that's certainly true in public health. You have most control at the local level, so
exactly.
So
yeah.
that makes sense. Yeah. Okay.
Yeah, just to expand on that, in some other parts of the world, specifically India, for example, I saw that in some cities and some states during the pandemic, they had much better control of the entire health crisis than others. And it all was tied back to how decisions are made at a very local level and how to implement the rules, okay? The nationwide, they had a lockdown, but still the implementation was done at the local level. So they were the people who differentiated between whether it was a success or not. So at the end of the day, it's the local government that has a very large say in how things are done, implemented, and then how we can perhaps improve for the future.
Are you in San Francisco?
Oh, myself? No. I kept saying San Francisco local in the spirit of San Francisco being local to US. No, I'm in Chapel Hill right here.
Okay.
Yeah, I live in Apex, Brian.
Yeah, I thought so.
Yeah.
We've got a couple more minutes. If anybody has any more comments or questions, or we can go ahead and wrap it up if you have nothing else to add.
It's been a great presentation. I have to run. Thank you.
Thanks,
for
Brian.
coming, Brian.
Thank you all for joining this morning. Very nice, exciting conversations.
Yeah, Sarah, thank you so much. That was awesome. If you all want to watch this again, it'll be on our YouTube channel if you want to share it with others. I think it was a very shareable presentation. But yeah, thank you all for coming, and we'll see you next time.
Bye, everybody.
Bye.
Bye, thanks.
Bye.